NumPy array indexing is quite similar to list indexing in regular interpreted Python, except in the case of a NumPy array, some of the methods are a bit more advanced than regular interpreted Python list indexing. So essentially, we're trying to get a value and then we specify the index of that value in square brackets. Okay, so in this tutorial, we're going to be looking at some of the indexing methods in NumPy array. So we have basic indexing, we have multi-dimensional indexing, we have advanced indexing. We're not going to be talking about slicing in this tutorial. In a subsequent tutorial, we're going to talk about slicing, but here we're going to be focusing on indexing exclusively. So without much ado, let's get into our IPython and then let's play with some NumPy programs. So now we could have, of course, I have to import NumPy as NP, and then I'm going to start with one-dimensional array. So you already know how this works. We do np.arrange, and then here we can specify our values. So let's say 10. Okay, and then we have 10. For indexing to work, I have to actually put this. I have to store this in. I have to point a variable to it. So np.arrange. So this is 10, and then array here. So then I can do array. So let's say I want to get the first value. Okay, so it's saying np dot is giving us the data type, and then the first value it's 0. What about this? 6. Okay, it's the 6. 0, 1, 2, 3, 4, 5, 6. Okay, so that's the 6th value in our array. Let's do negative. We have -1 because it gives us the last item here, just as we have in regular Python list indexing. And then we can also have something like this, -2. Obviously, that should give us 8. Okay. Now let's do for multi-dimensional array. Let's do for 2. No, let's do array 1, and then we can do np dot arrange. I'm gonna do, what is that, 12. Then I'm gonna do reshape 3 by 4, like that. And then when I do array 1, so we have a 2-dimensional array now. So we can index, we can do array indexing. We can perform array indexing for this and do array 1. Then when we do, say we do 0, 2. So here we say 0 is the first row, and then 2 is the third column. So this is saying, okay, get the, go into the first row. So this is row of index 0, 0, 1, 2. So in terms of row index, this is 0, 1, 2. So 0 refers to the first index, and then so this refers to the row index. This refers to the column index. So this is index 0. From index 0, get column 2. So column 2 will be column 0, column 1, column 2. So if this works, if I'm correct, this should give us 2. So let's see. Okay, so int 2. Okay, So you get the idea. If I do array 1, and then now I do 3, 2. Okay. Oh no, actually this is wrong because we don't have fourth row. So if I do 2 and then I do 3, so this is saying get the 0, 1, 2. So that's the last row. And then on that last row, get column 3. So column 3 will be 0, 1, 2, 3. So this should be 11. Okay, so this is working. Let's try for indices. For negative index. What if we did -1 and then we do -2? What is this going to give us? Okay, so this is giving us 10. -1 refers to the last row. Okay, and then -2 refers to the second to the last column in our last row. So our last row is this. Second to the last column is 10. So that works good. Now let's do for this is for 2-dimension array, in case you're wondering. So this is array 1 dot ndim. So that's 2-dimension array. And then if you want to check for the shape, dot shape. So that's 3 by 4. So 1, 2, 3. 3 rows. 1, 2, 3, 4. 4 columns like that. So let's do for 3-dimensional array. We can do np dot arrange. Let's have what is it? Let's have 24, and then we can do reshape. For reshape, let's do for 2. No, it's not correct. 2, 3, 4. Okay, so 2 times 3 times 4, 24. If whatever shape I'm specifying here also agree with the number of items in our arrange method, otherwise it's not going to work. So I can do this, for instance, and then AR2. Okay, so this works. What I said the other time is, for instance, if you do test array, and then we do np dot arrange, and then we do, I don't know, 25 items, and then we do reshape, and then let's say we do 2, 3, 2 times 3 is 6, and then we do 5, which is 30. This is not going to work. You see, it's blowing up. So whatever when we reshape, whatever shape we specify here has to agree with what we have here. So this is just to demonstrate to you that you can't just randomly set anything here. You have to be careful of the number of items that is going to spill out by the arrange method. Okay. So having said that, let's go back to our 3-dimensional array. So this is what we have. Is it 3-dimensional here? Okay, it's 3-dimensional because we have this dot ndim. So the number of dimension is 3. So the other time we said 3-dimensional array is a 2-dimensional array stacked on top of each other like a cube. So here we have so let's say our shape is 2 dot shape. So 2, 3, 4. That's our shape. So you can think of these two as the layer or the depth of a 3-dimensional array. And 3 refers to the number of rows, 4 refers to the number of columns. So you realize now that we have 2 layers, 1, 2. So this first value refers to the number of layers or the depth, if you like. And then the 3 refers to the number of rows we have on each layer. So you see on each layer we have 1, 2, 3 rows. 1, 2, 3 rows. And then for the value 4 refers to the number of columns that we have on each layer. So on the first layer we have 1, 2, 3, 4 columns. The second layer 1, 2, 3, 4 columns, like that. Okay. Now we can do indexing for this as well. Let's start with basic indexing. To do our basic indexing, we can do something like R2, and then we can do 0, 1, 2. So before I press enter, let me try to explain what it's going to give us. So 0 refers to the depth layer. Okay, so this is saying layer 0. So here, layer 0. And this refers to the row, this refers to the column. So essentially this is saying go to the first layer, get row 1. Row 1 is going to be, so remember, we start counting index from 0. So index 0, index 1. So this is going to be row 1. This 4, 5, 6, 7 row. And then this is saying column 2. So column 2 is going to be 0, 1, 2. This one. So if this works, I think we should get 6. Okay, so it's saying np.int64. So this int64 is the data type. So we're getting 6. Good. We can do more. We can do array2. And then here we can specify 1, 2, 3, like that. So this is saying go to the second layer. This is the second layer. Okay. Get row 2. So row 2 is 0, 1, 2. So this row 20, 21, 22, 23. This row. And then get column 3. So column 3 in this row is 0, 1, 2, 3. So this should give us 23. Okay, so we get 23. Good. We can also do for negative index. For negative indices now. So we can do -1, -1, -1, like that. Remember, in indexing, -1 refers to the last of whatever we are trying to do. So this -1 refers to the last, the first -1 refers to the last depth, that is the last layer. And then this -1 row refers to the last row, which is this. And then this refers to the last column that we have there. So if this works, this should give us 23. Or if I'm right, this should give us 23. So we press enter. Okay, so we get 23. Let's also do for this 0, 0, 0. So what is this going to give us? First depth, first row, first column. Okay, so let's see. So we get 0. Okay, remember, array2 here, first row, first column is 0. Okay. What else can we do? Now we can also, for instance, we can get an entire layer in our 3-dimensional array. So for instance, we can do something like AR2, and if we specify this, remember the first argument is, the first value in our square bracket is the layer. It specifies the layer. So when I do this, it's saying get all the values in layer 1. So we expect to get this. So this should give us 1, 2, 3. This should give us a two-dimensional 3 by 4 array. So I press enter, see, it's giving us this. So that's another way we can index our three-dimensional Numpy array. We can also do something like this. We can do 0, 2. Okay, so what this is saying is, okay, get the first layer, that is layer 0, and then row 2. So the first layer, this layer, then get row 2. So 0, 1, 2, 0, 1, 2. So let's see. She give us this. She give us 8, 9, 10, 11. Okay, so this is what we get. All right. We can also do for fancy indexing. But to do for fancy indexing, I'm going to start with what is it called? I'm going to start from two-dimensional array for our fancy indexing, so that we're not stuck on three-dimensional array all through. Okay, so let's do for fancy indexing, or no, let's start from what is it called? Let's start from two-dimensional array. From two-dimensional array, we can do so we can do, let's do array. Or should I know? Let's do a. Okay, let's do a now. Np dot arrange. Np dot arrange. What do I want to do? Let's do 25, and then I can do reshape. Reshape. Come on now. Reshape 5 by 5. Then a, it gives us this. Okay. So what can we do with what is it called? With fancy array. Okay. Fancy indexing, I mean. So when we do fancy indexing, we pass an array list of indices instead of slices, and then we return a copy. So that's the idea. So here we don't have any layer. We just have what is it called? We have just a single layer. What am I saying? Sorry, we have a single layer, and then our shape is 5 by 5. So 5 rows, 5 columns. Okay. Now let's see what we can do. We can select rows with indices, and then columns as well with indices, and then we can display a sub array for our fancy indexing. Okay, so there is a method np.ix underscore that gives us a clean way to do this. So perhaps I'm going to start with that. Okay, so let's do something. Let's do rows. Let's specify our rows. Can you 1, 3, and then let's specify our columns. We can do 0, 3, like that. So we're dealing with row 1, row 3. So row 1, row 3, 0, 1, 2, 3. And this is column 0, column 3. So column 0, column 3. Okay, so we're going to pass this into our fancy indexing method. So let's continue. Then we can do sub indices, and then we can do np.ix, like that. So np.ix, it gives us what it does is it gives us a way to perform open mesh indexing. So we get a cross product of indexes. Okay, so we can do np.ix underscore, and then some method, and then here we can pass rows, columns there like that. Now this sub indices, we're going to use it to generate our sub array. Okay, so now we can do sub array, and then we can do a, and then here we can do sub indices like that. Now before I press enter here and then display what we have, let me just explain what is going on here. So this is saying, okay, go to row 1, get row 1, get row 3, and then from row 1 and row 3, get the item in the first column, and then the item in the fourth column. So at the end of the day, we're going to get a 2 by 2 dimensional array. So if you press enter, what have I done wrong now? np.ndArray object is not callable. Oh, I think I blundered that because I'm sorry. So this is sub array equals a square brackets. Sorry guys, indices like that. Okay, so when we do sub array, see, we get 2 by 2 two-dimensional array. Let me show you our original array that we're working with. So this was our original array. We had what is it called? So remember, I think we specify for our rows 1, 3. So this is row 1, row 3, row 1, row 3. Okay. So for our columns, we specify 0, 3. So 0 column, third column, a fourth column rather. So we're getting 5. So from the second row, get the first, what is it called? Get the first column and the fourth column. So we get 5, 8. And then when we go to row 3, which is the fourth row, we're getting the item in the first column, and then the item in the fourth column. So that's 15, 18, like that. That works. Now we can also do for our fancy indexing, we can do for 3-dimensional array as well. So let's do something like, I think we had one before. Array, is it array 2? Okay, yeah, we have this 3-dimensional array before now. So we can work with this fancy indexing. It's not just np.ix underscore we can use for our fancy indexing. We can also do something like this, array 2, and then we can do let's have 0, 1, no, 0, 1, like that, and then we can have 0, 0. Okay, so remember, this refers to our depth, our layer, the first value here. So what we have, this pair that we have in our square bracket, is saying layer 0, layer 1. That is, from layer 0, layer 1, get the item in the first row and get the item in the first column. So I think item in the first row here, item in the first column here, like that. So the first column, first row, first column, first column. So this should give us 0, 12. Let me take that again. The first layer and the second layer. First layer, second layer. First row, row 0. So this is row 0. Okay? So in row 0, row 0, row 0, row 0 for the two layers, and then column 0 for the two layers as well. So column 0, column 0. So this should give us 0, 12. See? 0, 12, like that. So that's fancy indexing. Let's try another one. We can also do 2, and then we could have 0, and then let's have 0, 2, and then let's have like this. Have I closed that? Okay. Now, before I press enter, let me try to explain what is going on here. So here we're going to have a shape. We're going to have a shape. We're going to have a two-dimensional array here for the construct that we have here. Now this is saying go to the first layer. So everything we're going to be doing is here. Okay. Now it's saying in the first layer, get what is it called? Get okay, no, in the first layer, first row, third row, first row, third row, and then this refers to the column. So it's saying get all the columns. So go to the first layer, layer 0, get the first row, get the third row. So row 2 refers to this. So we're dealing with this and this, and it's saying get all the columns in row 0 and row 2. So this is going to give us an array shaped like 2 by 4. So we're going to get a 2 by 4 array, a two-dimensional array. So if you press enter, see, 2 by 4. So this is row 0. This is row 2, the last row here. So it's giving us two-dimensional array. Okay. Let's do another one. We can do AR2, and then let's do 0. Let's do this, and then let's do 1, 3, like that. Okay. So let's explain what is going on here. So go to the first layer. This is the first layer. Okay. Get all the column, all the rows. Sorry. Yeah. Go to the first layer. Get all the rows in the first layer. All the rows in the first layer. Now get column 1 and column 3. So this is column 1, column 3. Column 1, column 3. So I think if this works too, we should get a 2 by 2 array. Okay. Does that work? Okay. We should get a 2 by 2 array. Let's see. If I press enter. Okay. Now we get a 2 by 2 array. But then, I don't know, because it's saying get all the rows. So this is all the rows in our first layer. Okay. And okay, all the rows. Okay. And then it's saying column 1 and column 3. Column 1, 2, 3. Column 1, column 3. Column 1, column 3. 0, 1, 2, 3. Okay. So it's getting column 1, column 3. So we get a 159. 159. I just needed to be sure that I was correct with my explanation. So 159 and then 3711. 3711. So column 1, this, column 3, this, and then it uses it to form a 3 by 2 shaped two-dimensional array. Okay, this is nice. We can also do for, remember we had this NP when we did fancy indexing for two-dimensional array the other time. We had this method. Okay, we said we use it for open mesh indexing or cross product of indexes. Okay, so then we can pass some arguments here. Remember, our argument is always going to be in square brackets. So we have 0, we have 0, 1. What else could we have? We could have 0, 2, square brackets. And then we could have 1, 3, square bracket close, like that. So this refers to the layer, row, column. So this is saying go to, get the two layers, layer 0, layer 1. Okay, get row 0, row 2, and then get column 1, column 3. Okay, so if this works, we should get a 3 by 3, no, we should get a three-dimensional array, yes, shaped 2 by 2 by 2. Yeah, because we have 2 rows, 2 columns, 2 layers. So we should get a 3 by 3, we should get a three-dimensional array shaped 2 by 2 by 2. Okay, so we should get, let me just press enter. I think I'm doing too much of talking. Okay, so we get 2 by 2 by 2 three-dimensional array. So we get 2 layers, layer 0, layer 1. So this was fetched from what is it called, our 2 layers. So 0, 2, first what is it called, first row, third row. Okay, and then second column, fourth column. So we get this. Okay, what else could we do? We could also do for Boolean mask. So for Boolean mask, let's do this. Let's bring this back. Okay, so for our Boolean mask, we can pass some kind of Boolean array to filter the elements, and then if the position evaluated true, then we get what is it called? We get an array. So let's look at an example. We can do AR2, which is our three-dimensional array, and then here we can do AR2 greater than 15. So what we're saying here is get all elements in our 3 by 3 dimensional array greater than 15. So if we have elements greater than 15 here, they return. If not, they don't. So if you enter, okay. So these are all the elements greater than 15 in our 3-dimensional array. So 16, 17, 18, okay, like that. We could also have another one, AR2, and then we could have AR2 modulus 2 equals to 0. So this is going to give us, we're going to get an array comprising elements divisible by 2. So we get elements divisible by 2. So these are all even numbers now. We could also have something like this, AR2, and then square brackets. We could have this, AR2 greater than 5, and then we could have R and then AR2 less than 15, like that. So this is a Boolean condition. The left operand and the right operand have to evaluate to true for these to generate an array for us. So we're looking for values greater than 5 and then values less than 15. Okay, so let's see whether this gives us something. Okay, so we get values greater than 5 but less than 15. We can also do something like this, and then here we can do equals to 0. Well, you already know what this is going to give us. It gives us 0. Okay, so that's for Boolean masking. I think we've done quite a bit here in Numpy array indexing. So I think it will be appropriate to stop here, and then I'm going to see you guys the next video. I hope you've learned a thing or two in this tutorial. Okay, thanks for watching.